What's up, knife freaks, sharpness geeks, and purveyors of static goodness? Welcome to the Knife Freak Show. My name is Jonathan McNeese. This is my co-host, Mr. Chase Boatwright.
Greetings from beyond.
I imagine you're probably a little tired since you had kind of worked all weekend, huh?
Yeah, a little bit. I mean, it wasn't too bad. But yeah, did a little bit this weekend. As far as I just got done with the Mark's Outdoor Show down here in Hoover, Alabama.
Yep. I saw a few pictures from it. Looked like it was probably a pretty good show.
Yeah.
Anything exciting jump out at you?
Oh yeah. There was a lot of local makers mostly, and then a few guys from out of state. But yeah, I think I took 8 knives with me and came home with 3. I ended up trading one for another, but we'll get into that in a minute. But yeah, it was a really good show. It's always a great time. They take care of us very well down there, and they feed us lunch and everything. So I always enjoy doing that show. But before we get into it further, how was your week?
It was good. Yeah, it was good. We had a pretty good, fairly normal week in a way. The only real problem was we didn't get the whole schedule thing I keep talking about. We did not get blades back from heat treat when I thought we were going to, like at the very first of the week. So that kind of shifted us, and we didn't get as many knives built, period. And the knives that we did build was mostly Mac 2s because we actually had blades for them. So we had to kind of switch and do builds with those since we didn't have hardened blades for the Dixons to go off of. But the blades did come in at the end of the week, so we should be able to have a pretty much a solid week this coming week of building Dixons. So
Nice.
nothing crazy, just the normal ups and downs of the supply chain stuff and dealing with vendors. So
yep, that's constant struggle. Has been the one consistent, I guess, throughout this whole ride you've taken.
Yep.
That, and always constantly learning and trying to learn while you run, basically.
Yeah, exactly. I've seen the analogy several times lately of people talking about basically building the airplane while they're flying through the air. That is very much how it has been and continues to be. So
yeah, I think about it like in the newer Mad Max movies where they're they've got people down in the engine bay while they're in the middle of a gunfight, rolling down the road.
Mm-hmm.
So that's very much what it's like.
Yep, very much. You can't just stop. You just got to keep going and piece it together as you go. So
yeah, for sure.
But anyway, so yeah, tell us a little more about the show.
It was a lot of fun, and I ended up, like I said, trading for a knife. At the end of it, me and the other maker, his name is Aaron Glover, is the maker's name, but he goes by Scarfoot Knives. He's a guy I met down there a couple years ago. He didn't even have a table. I think the first time I met him, he was just making stuff on the side, sort of a hobbyist. He's an engineer by trade, but he had brought a few knives, and so they, Randy, but the guy that runs the knife counter down there basically just took the knives out of his hand and put them up on the knife counter and put prices on them to sell because Aaron wasn't confident enough to sell them at that point. But Randy knew how good they were. But now last year and this year both, he had a table there, and I've always really admired his work. And for those of you YouTube viewers, this is it. He called it the Phoenix. Every one of his knives, he names it sort of based on the story of the knife. And this was one that he had screwed up long ago before his skills were good enough to fix, and then sort of dug it out of the trash bin almost and made it good again. And so it has rose from the ashes, as it were. But there's one thing that he does that's particularly insane. He does great hamones, great fit and finish and all that, and very, like I said, he's an engineer. He's very detail oriented. But he reverse tapers his liners. He tapers his tang, and then he reverse tapers the liners. Is that making sense to you, audio wise? Or
the entire length of the liner? Is that what you're saying?
Yeah. So like he's got the handle scales and he's got the liners underneath, and instead of leaving the liners flat, and the tapered tang goes from basically like at the closest to the blade bevel, the portion that's the thickest point, and then down towards the butt of the knife is the thinnest point. Right. He does the opposite
on
for the
blade.
liners. Yeah, on a fixed blade.
So he does. So for the liners, they're thicker at the butt and get thinner towards the pivot.
Yes, towards the
Huh.
front, of the handle scales, towards the bevel.
Now wait, the liners though, not the blade.
No, the blade is the tang is tapered and the liners are tapered. The liners are reverse tapered to fit the tapered tang.
Are we talking about a fixed blade or a folder here?
Fixed
Because I
blade.
can't see it. Oh,
Fixed
holy
blade.
crap! No wonder I was like, man, I don't know near as much about knives as I thought I did.
Yeah.
This whole like not being able to see each other is really throwing a kink in this discussion. So okay,
Yeah.
I got you now. Yes, so they come. Yes, they're angling towards each other and they match up. Okay.
Yeah, basically.
All
So
right.
like,
Sorry, my mind was 100% on folders for some reason, and I could
yeah,
not make that work. So
no, you're good.
okay.
But like up close to like where the jimping is, like where the the blade bevel starts, the liners are real thin and the blade is thicker. And then down at the butt, the blade tapers off almost into nothing, and then the liners are thicker back there. And it's like a blood red G10 liner with black linen micarta and copper pins. I believe it's W2 is the steel with a nice hamon on it. I probably should have sent you a picture of it beforehand, but that would have
Next time we'll try to plan ahead and do that. That would
Yeah.
definitely have helped. A visual aid would have helped a lot.
Yeah, but Aaron had also bought a knife from me a few years ago, and so I've wanted one of his for a while, and it's just knife money is not as I guess easily come buyable as it used to be for me. So being able to trade him some of my work for some of his work, I always enjoy doing that with other makers.
Oh yeah,
But,
that's always cool too. To just you kind of end up with a better value out of it, in to some degree or whatever, and it's just cool.
Yeah,
to do the old horse trading, horse swapping.
Yeah, and there were two other things I wanted to talk about from the show. One, Mark Whitlock Jr. It's a family-run business for those of you that don't know, but he's like the third generation basically that's running the business now. I believe he's running it. But he is the Mark, or one of the Marks of Mark's Outdoors, and he ended up buying a folder from me actually. And
Cool.
It was sort of started from the fact that he was carrying McNeese custom sodbuster that day in his pocket that he had got you to build a couple years ago. Yeah, that was the one with the meteorite inlay and the sort of outdoors lasered landscape on it.
Like a mountain scene, very similar to the Appalachian Ridge or whatever one we do now, but with a meteorite inlay for the moon.
Yeah, and I recognized the clip in the pocket, and I didn't know if it was that knife or not. But when he pulled it out, I was like, "Yeah, I remember that. I remember the laser running for like 20 hours, just cutting that meteorite out."
Yep.
But yeah, so that was cool. And the other thing I wanted to mention was a little bit of knife safety, I guess, or knife etiquette at shows for those of you who attend on the other side. We had a gentleman come by, and he had been wandering around the show for a little bit. It's a fairly small show as far as, there was maybe 10 makers in there, and it's but he took one of Scarfoot knives actually, and was tapping it edge down on his forearm and trying to make the point that if you don't go back and forth, you can't cut yourself if you're just tapping straight up and down. And like I said, Aaron is meticulous about all things, including sharpening, and his knives are incredibly sharp. And so this gentleman ended up with some blood lines across his arm where he had just cut himself. So don't do things like that. And another thing he had done was he took another maker's knife. Good thing is he bought that one. He bought the one that he cut himself with, so that's good. But he also took another maker's knife and put it on the table and said, if it doesn't bend, I'll buy it. And he took a 12-inch bowie and flexed it and leaned on it on the table and did it both ways. And the thing is whether it passes or not is not the point. The point is it was not his knife at that point to do that with.
No.
And so, yeah, just don't do things like that, guys. I don't think y'all would do that, but just those were two things I had never seen at a knife show before. And so, yeah, just wanted to kind of share that funny little anecdote, I guess.
Yeah, that definitely kind of sounds like a typical local Yahoo kind of deal there.
Yeah.
Yeah,
And he had already come by my table and, was telling me that I should do all sorts of, I should do this and I should do that. And I was just like,
yeah,
no, no thanks. But
yeah.
in a
Gotta
polite,
love it.
yeah, but it was interesting. Next, I want to have like a knife bingo sort of situation for, first one to cut themselves, or a knife show bingo, like, who
Yeah,
cuts themselves, who drops one. I think that'd be a fun thing to do
right.
in the future. But yeah,
Yeah,
just,
I think it would too.
but yeah. So with that,
Wow.
we can move into frame locks and liner locks, and particularly the locking interface of those
Yep.
mechanisms.
The locks of the locks that makes things work.
Lock and load. I already said that last week, but that's probably
Yeah,
going to be the
that's
episode
all right. It's
name.
pretty applicable.
Yeah.
Yeah. So locking. Now, we're going to talk about strictly like frame lock / liner lock
Yeah.
locks, not because I'll be honest with you, I'm not anywhere near an expert on all the other locking mechanisms and stuff. Like there's a bunch of them out there and a bunch of really good ones out there. But so this is not a like encyclopedia of lock types. Just more how we try to make the locks on our knives function
Yes.
and how we do that,
Yeah.
basically the
Yeah.
process.
And again, this is a question from last episode. Tom Cook asked about detents and locking mechanisms and wanted to kind of hear more on that. So we're, sort of finishing the second half of the question now with the locks.
Right.
Where do you want to sort of start? Like with angles or with?
Well, let's lay out what the proper function of a lock should be. What constitutes a good lock? So obviously, the first thing I think that we could say is that it needs to actually lock. So like it doesn't need to fail. It needs to solidly lock open, and it doesn't need to fail. Right.
Yeah.
So that's the most basic principle. And so the once it is locked, sorry, I got distracted for a second. It thundered outside. No, Roscoe decided he had to come in the office for a little reinforcement here. You can't see him on camera, but he just pushed his way through the gate. Anyway,
Nice.
so the locks stays locked. All right, number one, by far the most important thing. And then that it really should not be any movement in any direction, really. I mean, not that the lock actually moving. Like we talked about in the last episode on the detent stuff, there's some things you can flex and you can tell that stuff's just flexing, but there's a difference between that and actual play, right?
Yes.
So so it really shouldn't have any, lock is what we describe as basically up and down movement. So, hey, I brought a visual aid today, and you may be over there doing it for
Yeah,
me. But
I
so
am.
lock would be if the blade was moving up and down this direction, like when it's locked. If you
Spine to edge.
try to wiggle it that way, right, that it's got movement up and down, and then side to side play is exactly what it sounds like. Does it
Flat
move
to flat.
right, flat to flat? So, and it really should not have either one of those things. Now, technically, it could have one or both of those and still be a safe, functional knife if it's got, as long as it's not unlocking, at least in the short term. Now, whether it'll maintain that in the long term, with movement going on there, who knows?
Yeah.
But that's kind of the basis, then we'll talk about getting into like the percentage of lockup and stuff like that, as with the caveat that it's locking and not slipping.
Yeah.
Then there's almost not really a truly wrong amount of lockup, again, assuming that it does not fail like ever,
Yeah.
So we'll get into like what we shoot for and why, but that to me would be the basis of a lock. Basically, it does what it's supposed to do. It locks, stays locked while it's supposed to lock. Well, one more little thing would be that it actually needs to unlock cleanly as well.
Yes.
So you don't want to lock. You don't want your knife to lock open and then have really don't want it to have any stick, but you certainly don't want it to have such bad stick that you basically have to take a pry bar or something and pry it open,
Yeah.
or pry the lock bar out so that you can close the knife. So I would say that's the baseline function of a lock that you need to have just right off the bat. So anything else on that you can think of?
No, I would agree. It just needs it needs to, like you said, function in the locking part, and it also needs to be able to disengage and allow the knife to be closed again, and that sort of thing easily.
Yep. So lock, unlock, and ideally no movement while it is locked.
Yep.
So all right. So then I guess let's start with the angles, because with locks it's pretty much all about the angles, right?
Yeah.
So what are you still cutting yours at like 8.5 degrees?
Yeah, I'm right at 8.
Okay. Yeah. And I think we're right in there. I think we may be a little higher than that now. I honestly can't remember, because we played with it up and down the scale some when we got set up doing our current lock setup. I think we're somewhere around, we may be actually closer to like 9, somewhere right in there, but somewhere in that range. Usually I think most locks that you see out there are going to be cut between probably like 8 degrees and probably like 10 degrees, somewhere right in there. You start getting outside of that on either side of it, you're either getting a lot of stickiness or it's potentially going to fail.
Yeah.
So that kind of seems to be the ideal window right in there.
And so when we're talking about angle, by the way, guys, we're talking about like if you have a blade laying flat on a work rest, it is the angle that the tang of the blade, the actual lock face of the blade, is being ground. So instead of just a straight up 90 like most of the rest of the profile is going to be, it's angled specifically for this.
Right.
And I'm guessing Michael Walker figured this out back in the day, like figured out the angle.
I'm sure him and or Chris Reeves with the on the frame lock, So what Chase is describing, so if you can imagine the lock bar, which is the spring on the knife, it when as the blade is opened, it reaches a point where the lock bar gets clear of the blade, so it's riding on the blade, like we talked about the detent riding on it, last week. And then once it gets almost opened, the lock bar is going to fall off of the blade, and then that spring is going to automatically push it to the side, right? It's going to trying to push it behind the tang of the blade. And so when it's coming behind the tang of that blade, it's not a square. You're not looking at a 90-degree angle as it comes behind it. That the blade is cut at an angle to allow the lock to come over and travel a certain amount and hit and stop. So it's really mostly the leading edge of the lock bar. It's hard to ever really see this because it's not that extreme of an angle, but technically it's kind of that leading edge of the lock bar that's actually making contact and wedging itself against that angle. So the angle goes from like kind of more opened up, so it's angled like, I'm trying to figure out how to show it like with my hand. So it's angled to the side, and so the lock bar comes in this way, and it's from that direction. You got less amount of metal over here and more over here. So it's like a ramp essentially, and it's wedging itself against some point on that ramp. I really should have thought ahead and had a whiteboard or something in here, because that was a horrible mime deal there.
Yeah.
Anyway.
This is a really hard subject to not explain, like to try to explain without visual aid. So we're going to try to do our best for you audio listeners, but it's a dicey one at best.
Most of you probably have some idea of what we're talking about already, though, so that should help. So essentially the tang of the blade is cut at an angle. So as the lock slips off the blade and starts to travel across the tang of the blade, it is traveling across essentially like an angle or ramp, and so it's going to be running into more material as it goes across to a point where it's going to wedge itself against the tang, is the best way I could describe it. Now, some people do actually cut a angle on the face of the lock bar as well. I don't, never really have, and never really felt the need to do it. So I can't really speak to that a whole lot, but just that is a thing. Some people do that.
Yeah, I've never really done it intentionally. I've had it happen accidentally because my mill jumped or slipped or something like that. But otherwise, no, I've never done it intentionally either. I just
Yeah.
prefer to keep it straight 90 and, go from there.
Yeah. And I think the goal, if I understand right on that, is like just like what I was talking about, that as the since the leading edge, that lock bar is coming across that angled face of the tang, as the leading edge is essentially what is going to make, kind of get stuck first or whatever. Like it's what's going to wedge behind there first, and basically you're milling a matching angle so that by the time it wedges itself behind there, basically the whole face of the lock is making contact instead of just that leading edge, is my understanding of why some people choose to do that.
Yeah.
I think it's supposed to, maybe, I'm not honestly sure, maybe help with lock stick, or I'm not sure, although that's more surface area making contact, but
Yeah. I
it's
was,
not a corner, so I could see where it would maybe, I don't know.
yeah,
I'm not
maybe
sure.
not having a corner jamming into a flat versus having
Yeah.
a flat kind of rub into another flat. Maybe, I don't know. I've never,
Yeah.
tried it, like I said. So,
Yeah, I know that people do it, but I'm honestly not 100% sure what
mm,
the advantage is supposed to be. But anyway, so back to how we do it. So, like we said, that angle that the blade is cut on is cut at, somewhere between usually 8 to 10 degrees. And so now there is one difference in the way, well, besides the actual technique that we use. It's a very, very similar technique that we both use, but you're actually cutting your locks still flat, correct?
yep,
On a flat platen.
yep, using the
So
flat
you want to
platen.
maybe kind of run through how you do that real quick, and then I'll tell them, explain the difference in that and what we do.
Yeah. So with me being a custom guy, that means I deal with a lot of different models and a lot of different variation as far as thicknesses and sizes and things like that. So this is, how Jonathan did it, back in the custom days as well. But it's, you know, like I said, a work rest against an angled platen. Basically, what you do is you take generally on a frame lock, there's a little bit of a gap in between the where the lock bar is and where the blade is. Take a razor blade and scribe that line while it is in the open position and being held in the open position. And this is still when that material is still beyond where so the lock bar can't fall, basically. And the
Yeah,
point
and
is
can
to grind that material back. Sorry.
No, that's fine. And I can. It may make way more sense if they're being able to see what you're doing. I'm not sure, but what he's describing, guys, is so the lock bar cut, the cut that goes all the way down the lock bar and then turns that, and the cut in the titanium that makes that actually creates the lock face of the blade. So what he's talking about when he's talking about scribing it is in the open position with the blade held fully open. You take a razor blade and you try to run it right against basically the face of the lock bar, so that the tip of the razor blade is scribing a line on the blade in that position. So it's so that you know where to grind to. Like that
Yeah.
basically is marking where the lock face of the spring and the tang are going to meet. And
Yeah.
so just basically just running it right down. You just trying to hold a razor blade as close tight against that lock face as you can and scribe a line. So anyway,
Yep.
so go ahead from there.
Yep. And then from there, it's take it to the grinder. Usually, these days I've been using a 120 J Flex belt and going real slow, basically, and
Yeah.
removing a little material at a time, checking and double checking. It's back and forth of putting the knife back together again, taking it apart. So like, a lot of makers have said it, but by the time a knife gets to somebody, it's been taken apart and put together a million different times or 1,000 times
Yep.
or something like that between all
It's
these
really
different
trial and
processes.
error fitting.
Yeah.
Yeah. You scribe the line to have a reference point, but you can't, number one, it's almost impossible. I mean, maybe without like having it under some kind of magnification or something, you can't scribe perfectly to the edge of that line. And even if you could, usually your scribe, like the way you're having to hold the razor blade and run it down to there, it's not usually an exact perfect, line. It's not like that is truly the exact spot where it needs to be ground to. It's basically just giving you a reference point, and like, and for reference for you guys, the thickness. So we're talking about just like a regular, actually the thin razor blades, not like the thick utility
Oh
blades,
yeah,
but
like
like
scraper
the
blade.
little thin, like scraper blades. Like the thickness of the line that creates, like if you grind, say, to the point where you just start touching that line versus grind to the point where that line disappears, are two complete, like you could go from your knife being perfect to being completely ruined. Like
Yep.
that could make the difference between like 10% lockup and 100% lockup. Just the thickness of that line. That's how sensitive it is. That's how little material it takes to make a difference in the lockup.
Yeah.
So
because you're dealing with the spring comes over in a curved sort of motion, because
right.
it's held on. It's not an entirely free spring, so I mean it comes over in a curved motion. So again, like you talked about with detent, you're sort of dealing with a little bit of rotation type
Yes, it's an
geometry,
arc.
an
That's
arc
right.
type
It's moving in an
geometry. Yeah,
arc, and it's and hitting against an angle.
yeah,
So like there's a lot of variables there. Like I mean, it takes a tiny amount of difference to go from, like I said, 10% lockup to 90% lockup is a very, very small amount of material difference.
yeah. And then once usually I end up stopping a little bit short where it's still not locking up, and then go check it, and just because I can always take more material away, so you always want to be cautious and stay on that side of the line if you're second guessing yourself. But then we get into sort of like the lock percentage, like how much lock percent do you want, where do you want it to end up, and if it's too early, you take off a little bit more very carefully. Mind you, sometimes I don't even turn the grinder on. I'll just hold the blade up against it and spin the belt, and that'll move that 5% or whatever I need to get it to the proper lockup. But yeah, that's basically how I set my locks at the current moment.
Yeah. So there is one other thing that we haven't mentioned yet that comes into play here, and that's the rake angle. And a lot
Yes.
of you probably have never heard of that. The rake angle is, so what you want ideally when a lock is making contact. So we've described how the spring comes over behind the tang. It's coming against behind that angle, right? But you don't actually want the entire height of that lock bar making contact, or well, actually they're opposite. You don't want the entire tang, however wide or tall the tang area is on that particular design. You don't want the entire thing making contact with the lock bar. You want probably, well, again, depending on how long, because some tangs, I mean, some designs the tang is 3/4 of an inch long, and some of them it's like 1/8 of an inch long.
Yeah.
So for the shorter ones, because most of ours are kind of like shorter, most of them are probably longer than 1/8, but shorter than 1/4. So just say a little less than 1/4 of an inch. You don't want the entire height of that making contact evenly with the lock bar, because if you do that, you're probably going to end up with lock rock, the vertical play that we were talking about. One end of it can wear more than the other, and so then it's like the blade is like rocking because the tang is not hitting evenly.
Because
it's wanting to rock.
Yeah, it's hitting at multiple points basically. Because I mean, even though that titanium is flat, I mean it's you're dealing with the rotation of the pivot and the flex and those sort of things. So I mean, you end up with a situation where it's contacting multiple points and therefore causing
right.
I guess play.
Lock rock.
But,
Basically,
yeah, I
play in the vertical.
I feel like I just explained the thing we were saying the whole time, but sorry.
Yeah. No, that's so to avoid that, what you do, and what that angle is referred to as a rake angle. So what you, at least that's what we call it, and most of the people I know call it. But so what you want to do is, so like the way he described it, where he scribed the line down the tang of the blade. So what I would do, and I'm sure it's the way he's still doing it too, is when you grind the blade, you're actually kind of, when you're grinding, just manually looking at that line, and you're trying to grind, even with the edge of that line, I would actually angle it just a little bit. So I'd put a little bit more pressure down at the what I would call the bottom of the grind, whatever. So let me just, so if you're looking at it,
Usually on a right-handed folder, it's towards the spine of the blade. You want
right. So if you're holding it like this and looking down at your lock engagement right down in there. So if you call that the top and where it's making contact, and so farther down on the tang towards the spine, it would be, that's where you don't want it making full contact. So you kind of want it to basically be tapered so that it's making contact. I would say at least, again, depending on the length of the lock face. You definitely don't want the tang coming to a point, because then it really digs into the lock bar. But you want it to make some contact, but you definitely don't want that last little bit. So we would
I've got it sort of like very exaggeratedly drawn for our YouTube audience, where basically you just sort of want the bottom half, the edge side half, or portion of the blade making contact. But like I said, this is very exaggerated, but just sort of to give a visual.
Yep. And like I said, that varies depending on the length of the tang and stuff too on the particular model. So, but basically you just want some relief down there at the bottom so that it's not making contact all the way, or top, whatever you want to call it. This is Chase and I have argued over what it's called for years. The part that you can't see when you're looking down at your lock face, which is why I call it the bottom. So the spine side of that tang, you want it to not be fully making contact down there. So you basically grind your line accordingly. So like if you were trying to grind through that line like Chase described, what I would always do is like I would stop to where I was just barely touching the line at the portion that is at the
contact
top
point.
Again, I'm struggling because I'm wanting to call it top, and I know you're calling it the opposite. So
no, we always had that argument on detents as far as top and bottom. I don't remember having it.
Oh, okay.
It was when it was in the closed position, things got weird as far as what we refer to as top and bottom. But
all right, so for instructions, like we're gonna call top this side, right? So the finger choil side here. So if you're looking here, basically we grind it so that it was just touching the line here, but the line would start to disappear at the other end of the line. So that creates an angle on it so that it is not hitting the entire face of the lock. So it creates a little relief under there.
Yeah.
So yeah, that's another pretty important factor, because that can definitely cause you issues if you get that wrong either way. If you exaggerate it too much, it comes to too sharp of a point, it's going to start to really dig into the titanium spring, and it's probably going to be sticky, and it's going to cause a lot of excessive wear. If you don't make that relief there, there's a fair chance you're going to end up with lock rock. So it's a pretty important little factor there.
That's the whole, everything is a sliding scale of one issue to the other, like we were talking about, as far as, you just said, like stickiness to lock rock, or, with, and you can also end up with slip at, if you don't end up doing the angle right. If it's too steep of an angle, it'll want to slip off there. If it's too shallow of an angle, it'll come over and stick and not want to be able to come back out. And so that's why all these things are like very important to this process. Is it either way, either side of the line you fall, if you fall one, too much one way, you end up with issues.
That's right. Yep. There's a little bit of wiggle room kind of in the middle there, but but there's definitely, you definitely have to kind of stay between the guardrails, or you're going to have issues for sure. So and while I'm thinking of it,
Alan Elishewitz did a video. It was probably 2 or 3 years ago now. I think it was on his Instagram, but it was a very, very informative video about this whole discussion.
And so he literally did draw it out on a whiteboard and make it much easier to comprehend.
Yeah, so if anybody wants to see that video, I think I've got it saved on Instagram, so I can send it to you if it's still, assuming it's still up. But
or just go to Alan's page and scroll back a ways. Like I said, I think it's been probably 2 years or so since he did it. So
it might have been more than that. I think we might have been in the original shop.
Oh wow! So yeah, it's a ways. But anyway, might be easier to just let Chase send it to you.
Yeah.
But anyway, so how about we'll Now let me kind of describe the difference
Yeah.
between how you cut yours, and then we'll get into the whole the percentage discussion, since that kind of gets us back to the same place, you know.
Yeah. So
Um,
I cut mine on a flat platen, but you cut yours differently now. And
yep.
how do you do
We
that?
do a radius cut. And if you go, those are any of you that are knife makers out there, if you fool with voters, you're probably familiar with Bob Trerzola's book. He calls it the no fail lock when it's cut on a radius, which is a little bit of a misnomer because you can still do them wrong. And if you do them right, they won't fail for sure. You can still do them wrong. Just because they're radius don't mean they won't fail. You can for sure still mess stuff up and cause them to fail. So
Oh, yeah.
basically, it's very, very similar to what Chase is describing, except that instead of pushing it against, so what he's describing is he's got a flat platen here that's at an angle. He's got a table that the blade is sitting on. The platen is at an angle, so when you push it against and when the platen is what the belt travels over, right? So that's the pushing against the grinder at an angle. So it's cutting that angle onto it, that 8.5 or so degree angle. So ours instead is pushing against a little 2-inch contact wheel. So the belt runs around a wheel so that when you push it against it, it actually cuts a concave radius into the lock.
Like a
And
very,
so,
very small hollow grind, basically.
yeah, exactly. And so to determine that angle, it to get that 8.5 to 9 degree angle in there, it basically depends on how high you have the table set versus the center of the wheel, kind of. So because you got to think about it, you have an angle and you start angling it around the wheel, like it's round, so it's not
Yeah.
really an angle anymore. Like so, you can't just like lower the work rest because then it's no longer, at least in my mind, I may be missing something, but because I actually have seen people with an angled work rest before, and I couldn't understand why. But maybe
Yeah.
I just don't understand something about it. But what we found was that by raising and lowering the height of it, so where the tang hits the wheel, because if you're say you're taking a scoop out of something like this, whether you have it up here and the deepest part of the scoop of the concave part maybe is down here versus up here if you've got the part lower to the here. So you see what I'm saying? So like the center of that radius changes versus
Yeah.
where
It,
you
it
align it to push it into it.
yeah.
And
It very much
so,
matters where you take that, scoop out of and where that
right,
initial,
you need the
where the center
center of the
point of that
radius in the right spot, which
scoop
essentially
comes in.
creates that angle.
Yeah.
Right. So we just basically had to play. There's probably some mathematical formula that we could have done if we'd have been smart enough to be able to do it, but we just basically played with it. Started close to like center line, and then played with it until we found what worked, and lots of testing and spine whacking and seeing if they fail or seeing if they stick and that kind of stuff. And
So
so,
I do have a question on that. Like, is
all
the
right.
center of the wheel sort of at the top or like the parallel with the top flat, or is it, lower than that, or
So
like,
if you imagine the knife laying down and the center line of the blade as it's laying flat, right?
hmm
So if you slice the blade in two, laying flat, the center line, I'd honestly have to go in there and look at it to tell you for sure because we've had it set and just left it alone for so long now. But
yeah,
I think that it is center line of the blade is slightly below center line of the wheel, if I'm not mistaken. I'm
okay.
almost 100% sure that's right. It's not.
So it's not to the
It's
extreme of where it's all the way parallel with the other,
no,
like
no,
the center line's not with the other
no,
flat. Okay.
no. It's a little bit below center line of the blade. Is a little bit below center line of the wheel. I'm pretty sure is where we ended up landing.
Okay.
So I can look at it later and follow up with you, but I'm pretty sure that's
Well,
the way
no,
it
that,
is.
that makes sense because I think the idea is for, not for the scoop to completely, you want to have the radius a little bit in the middle,
Yeah,
not
yeah. It needs to be
entirely in the
close
middle,
to
but
the right.
yeah.
Yeah, it needs to be close to. I think a little bit closer to the. So if so if
To the
most of us
lock
are
side.
familiar with lockup percentage, right to the side the spring is on. So like when
Yeah.
it first starts to make contact with the blade, or where it first starts to go behind the blade. So in that direction, you would want the radius to be slightly favored to that side.
Yeah.
So then you have, because it makes the radius, and you want enough meat coming around on the back side of the radius, so that it will stop the spring as it's coming over there, and not let it just keep going all the way to 100%. So the one thing that we have found that's tricky about doing the radius cuts is, because it is a radius, you can go from, like, we can cut it and very early and having it, like, say, like 10%. There's almost no middle ground between like 10% and like 35%.
Mm.
Like, because it's a radius, and so it's like you get to this certain point, and then if you cut it just a little bit more, it'll go from like 10% to like 35%. Like, there's almost no in between.
Well,
Um,
back to what we said. I mean, you're already dealing with the arc of the spring, and now you're adding an arc for that arc to land on
right.
instead of
And
an
so it basically just
angle.
kind of,
So it's
yeah, so it reaches a point where that arc's a little deeper, and it just kind of bypasses it until it gets to the point where the curve starts to intersect with the path of the lock again as it's making its arc. And so, yeah, it's, again, that was just something we had to trial and error, and we figured out pretty quick that, hey, this is there's not a lot of in between there. So we need to usually err towards the side of a little bit on the early side, because it can move over really quick if you're not careful. And the difference between landing at 35% to 60% is like you breathe on it too hard. So the one thing that we do slightly different as far as how we do it, I mean, other than going against the wheel, it's still the same concept, but we don't just lay the blade down on a table and push it against there anymore. We don't actually scribe a line. So what we do is we have this little thing, and I got to give shout out to Les George on this, because I totally copied his homework on this. He showed me his setup, and I got the stuff to basically replicate it. So it's this little, I don't know what it's called. It's this little sliding mechanism. So it's like a base, and then it's got a top plate mounted on it that's spring loaded, and it's like this, like dovetailed, or so. I'm not sure if it's technically dovetailed, but something like that. So it slides like a
yeah,
drawer or whatever. You know what I mean? So you got a base that's mounted firmly, and then you got the top piece that slides. And so we have that mounted on there, where the tool rest would be. So you got the wheel, and so then we have this little plate mounted here that's got the sliding plate on top of it, and then we actually make an aluminum plate that bolts down on top of that, and that gets a pivot barrel put in it, and a little stop pin. So you put the blade up there, you lay it on you put the pivot barrel locates it. You put the pivot, barrel, or the blade on there with the pivot hole going over the pivot barrel.
yeah,
That was way more complicated to say than it is to do.
yeah,
And then you rotate the spine against the stop pin and hold it firmly there. And then the sliding mechanism allows you to just slide it against the belt, back and forth. So it's kind of the same difference, but it keeps it moving in a pretty perfect straight line.
yeah,
Whereas, when you're just pushing it manually, it's actually pretty difficult to
yeah,
keep it going perfectly straight against the wheel. And
yeah,
so that rake angle that we were talking about, that is factored in with where we put our stop pin. So you have the blade on there, it's sitting on the pivot, and so it rotates around till the spine hits the stop pin. And so we played with it until we got the rake angle so that it cuts a little more off of that bottom part of the tang so that it doesn't make contact. And so then that's where we set our stop pin. So now when you take the blades and you push them against the stop pin, we get more or less the same rake angle every time automatically. There's still a certain amount of, and so this thing also has a dial on it, kind of like a caliper dial. And so unfortunately, it's not as cut and dried as just, okay, go in there and cut it to this number, say like 10 or
yeah,
whatever. It's just a dial with numbers on it. It's not as cut and dried as being able to just say, okay, just go in there and cut all these blades to 10. For one thing, you have the wear on the belt, on the abrasive belt, makes a lot of difference. If you put a fresh belt on there, and so that when I say it has a dial, the dial has a stop. So you can you dial it, and it'll adjust where the stop hits. So you're limiting how far it pushes into there. So you can set, like, how far you're wanting it to make contact with the wheel, with the belt. But again, you have it set at that exact same spot, and you put a brand new belt on there. Say you were using a really worn belt, a lot of the abrasive is worn off of it. Well, that belt's not as thick anymore.
Yep.
So if you take that and you just cut one at 10 and it was perfect, but you decide it's time to change the belt, and you throw a brand new belt on there. This belt is now thicker. It's got more, sharp abrasive on it. It's going to cut way more efficiently than that worn out belt was. So you put it on there and you cut it to 10, and it's probably going to be at, beyond 100% lockup because you didn't factor in the belt. And a lot of that is honestly just like, even if you take, two blades back to back, where there's not that much wear difference in the belt, like they don't necessarily always hit just dead on. Matter of fact, we found that two different people going in there and cutting a lock, like having the dial set so that it stops at say it's on 10, and so you bump it, and so the stop is like a hard stop. It hits against it, and so at that point it can't push against the belt anymore, except it can. Because this is not like some huge, massive, rigid setup. You know what I mean? It's like there's a certain amount of play there. And so just how many times, like, because we don't usually just push it against there and hold it. We usually kind of do it in like bumps.
Yeah.
And so how many times you bump it, how much pressure you put on it when you bump it, all of those things cause more or less material to be removed. So we would find that two people could go in there and cut it with it set at 10, and one of them would be perfect, and the other one would, the lockup would be at like 80%, or vice versa. One of them would be just right, and the other one would be at not even locking up. So there's still a lot of touch to it, and now for the most part, we've got one main guy that cuts all the locks, and so he's we at least eliminate some variable there so that we don't have multiple people trying to do it. So. And we always have to kind of, if you have to start over, you put a fresh belt on there, you do whatever, you have to kind of crank the dial so that it stops way sooner, far enough that you're safe, that you're not going to cut too much. Do it, and then just like you said, we're still taking them in there. Each knife that's getting fit up is being taken in there with the blade in it. It gets hit on there, ground, put back in the blade, opened up, checked for lockup. If it's not quite enough, goes back on there. Get some more, so on and so forth. So it's still every single one is getting fit up specifically, like by hand, by touch to work properly with that set of handles. Nice. Which is also a reason, just a side note here, one of the reasons that and the whole discussion we had about the detents and how much a tiny, like almost imperceptible to the eye difference in some sort of tolerance, like that stuff is so finely tuned to such a small tolerance that's why you can't swap blades in these knives, guys. Like you can't. These are fit up. Each detent and lock is fit up specifically for that set of handles and the lock side specifically. But honestly, we've found that even changing the show side can change stuff on some things, but lock side for the most part, because that's where the detent and lock fit up goes. Yeah. So that's why you can't just take and do a blade swap and expect that everything's going to work right. You might get lucky and it might still be okay, but it's almost guaranteed that it's not going to be exactly the same. There's a really good chance it could be way off. Yeah. You may be fine in one set of handles and you may have lash or way too light of a detent or something like that in another set of handles. So because there's so much hand fitting that goes on that once that blade gets mated up with a pair of handles, they're like turtle doves. They're mates for life at that point. Like they're joined. That's it. And there's no swapping them around. So anyway, back to the process. So yeah, at that point we're kind of doing basically the same thing. We're using our little slider table thing and bumping it against the wheel, but we're still taking it off, checking it, seeing if it's where it needs to be. Cranking the dial just a tiny bit, hitting it a little bit more till we get it right, and then, so it's a lot of hand footing that goes on in that process.
Yeah.
So
it definitely sounds way better than your previous process that I was very privy to. But yeah.
You talking about the way you're doing it now, or
no, the way we used to do it for you
when we were
on the side plate?
Oh, yeah, on the surface grinder.
How we originally did it.
Man.
How I originally did it, yeah.
Yeah, I had completely forgotten about that. Yeah. And some people still do it that way. Some of the bigger companies, I think, do it that way. So what we would do then, guys, so you know what we're talking about, it's very similar process to what we just described, except we would use what's called a sign plate, which basically is a plate. It's two plates like in an L that have a hinge at where they join up, and it would be tilted at an angle. You can adjust the angle on it. So we had it set at a specific angle, which equaled that basically 8.5 degree, 9 degree angle. And it's kind of the same deal. There was a pivot through it, so the pivot or the blade would go on the pivot, and it would get pushed against the stop pin. It would get clamped on there, and then this plate is on the magnetic chuck of a surface grinder, and so it would be held up there at the correct angle, and then we would bring the surface grinder down, and we would just go back and forth across it. And even though our surface grinder was a wheel, well, they're all wheels. Ours had a belt with a contact wheel, but because we were going back and forth and not just plunging straight down into it, we still ended up with a lock face rather than a plunge. Yeah. We tried it both ways actually, but we ended up settling on the flat going back and forth. And basically the same thing. We would put it on there, and on those were we still scribing a line on all of them?
Yeah, for a long time. I mean,
yeah. So we would do the same process that Chase described. We would scribe a line on there, but then we would just be turning the wheel on the surface grinder to lower the wheel so that it would take off a little bit more. And you're trying to take a flashlight and look at it, get it so you can see the line, and try to creep it down there till it just barely grazed the line, and then take it off, test fit it, put it back on there, take a little more off, hope you didn't take too much off, all that fun stuff.
Yep.
So yeah, this is definitely way more efficient than that process works. But
it works. Yeah, I'm not denigrating it, but I mean, no, it's definitely effective. If once I get that surface grinder back up and running, I'm hoping to sort of replicate that setup. Or I mean, I would like to try the radius out at some point, but like you said, it all depends on the blade thickness, and also I'd have to make sort of a modular plate for my different models where they had different stop pin locations all in it, and I haven't been able to quite
run into that
out my brain.
Matter of fact, we just we solved it for switching back and forth between the Mac 2 3.5s and the Dixons like just this past week, I think it was. We've been trying to figure it out because the actual locks themselves, it's the rake angle that messes you up on there. Like I said, knowing where the stop pins need to be because like super sensitive. We're talking about tiny amounts of difference, of how much you have the blade rotated. And so basically we put it on there. We put say a Mac 2 3.5 blade on there, and we cut it and made sure the rake angle was where we wanted it, and then clamped the blade down. And I took a hand drill with a drill bit that was the right side that is the right fit for our pins that we use. Yeah. And I just basically took that drill bit and pushed it right up against the spine of the knife where I wanted to. It held it against the spine, spotted the hole with the bit actually, rubbing against the spine. So I knew it was right up against it, and then moved the blade, drilled the hole, dropped the pin in there, and it works fine. And then repeated that for the Dixon blade. And so now the pin's a slip fit. It's not super, super tight. It's loose enough that you can just pull it out with your fingers. So to switch back and forth, you're literally just taking the stop pin and moving it from one hole to the other. I'm hoping we can do that, incorporate the 3-inch blade in there for that too, for the Mac 2.
Yeah.
At some point, the next time we cut some of those so we can keep them all on the same plate.
Yeah. And the other factor for me is, I'm setting all these open and closed positions and setting all the spines or, doing all the profiles by hand. So there's already more variability there for me in that,
for that,
just going off of the spine. So that's
because if your spines are not the same, exactly the same, so if you've got the exact same blade profile, but you actually ground just a little bit more off the spine on one, on this one versus the last one, well, then it's going to change your angle if that's what's determining, if that's what you're butting into. And that was a concern of mine. And for a long time, we basically had a stop pin set up.
I would like to try the radius because
and this is where
I like the way
they
function and I like the way they work and stuff. But it's just
because you don't have enough room to put multiple stop pins typically in the same, unless your blades is like noticeably like the profile is way different.
Yeah,
because what happens if you make your stop pin on your fixture so that it hits in the actual stop pin location of your knife, so like the open So that's one other factor we didn't mention, guys, is that the open position where the blade hits the stop pin is that has to be set and done before you set your lock, because obviously if you put more or less material up there, it's going to tilt the blade. So it's going to tilt the blade either, it's going to let it either go up farther or it's going to tilt it this way more. And if you imagine, as it's right here at this lock, that's going to make that material either kick back or kick away from the lock. So it makes a ton of difference. So if you have your lock set and then you go back in there and you try to grind and clean up this area where it makes contact with the stop pin, you just completely screwed up your lock fitting, because it just changed the location that the lock is based off of it resting against the stop pin at that specific location.
Yep.
So if you replicate that on your little plate that we're talking about, so if you have the stop pin, instead of having it on the spine, if you have it so the blade is actually hitting it at the open stop pin location, and it's already cleaned up and set, well, then it's basically guaranteed to be right in relation to that blade, because it's the same stop pin location that it's going to be on the knife. Does that make sense?
Yeah. Yeah.
You take out that extra variable.
I thought you
stop pin location set. Go ahead.
Yeah. But I still don't know if it's that consistent from knife to knife. And, there's times when things go too far and I have to go from one size stop pin to another. So that changes the final stop pin location there. And,
that's a good point. Yeah, you got to have, and that's, so the difference being that we're talking about, guys, is that, Chase is he's grinding in those stop pin locations by hand. And, I don't know how else to say, he's grinding them by hand on the grinder, whereas our stop pin locations are set on the mill. They're milled, and they're one of the more precise things that we do on the mills. Like, we're very careful with those. Like, we make sure that they're, we do some stuff on there that makes them, like, they're more critical than other areas. So we make sure that they're as good as possible coming off of the mill, so that they don't have to be touched, because we don't want that variability that he's talking about. So that would be kind of a factor for you there.
Yeah. So sorry, you guys that are listening. This is sort of just me, I guess, picking Jonathan's brain and that sort of thing. But I figure that's partially why you're here.
Yeah. So I think that's got a pretty good description of how we do it. Now I think probably a good time to finish off with talking about the percentages and stuff.
Oh yeah. So
what
for
percentage
me,
are you shooting for?
Generally, I try to land in the 20 to 30% range, somewhere in there. I like to go a little further than you typically did when you were building customs. I prefer that little bit of extra ease of mind. And what we're talking about is, if you look at if you're holding the knife and looking down at the lock face and seeing how much that spring is bending over, we're talking about the percentage basically. And, it's all like a eyeball test, but roughly the percentage of the blade that is being covered, I guess, or, traversed before it's making lockup. So, if it's hitting directly in the center of the blade, right behind the grind, that would be 50%. And, on both sides of that, that's, a swinging spectrum. But, if it's barely touching the edge of the tang of the blade, at 5 or 10%, that's sort of what we're looking at. And versus if it's swinging all the way over to the other frame, that's basically 100%.
Yeah. So starting as that lock bar starts to travel across the face of the blade, like we talked about at the beginning, the point where it starts to go behind the blade would be basically zero until, once it starts actually getting behind the blade, then you're at, 1% and whatever on down the line. And then as it travels across, and what we're also talking about is the leading edge of the lock bar, because I think maybe sometimes people get a little confused too on that. And so you're talking about like the leading edge as it goes across behind that lock face, where it lands. Like Chase said, the easiest thing to do is try to visualize where halfway is, and then kind of like reverse engineer it from there. And so I think that's probably the 20-30% is probably just about as close to ideal as you can get. That's pretty much what we shoot for these days too. And like you mentioned, back in the custom days, now I was notorious for making them really early, but it wasn't just me. Like that was, I think that trend has kind of changed over the last several years. And people get a little antsy now if you have one at like 5%. That used to be like a bragging thing. Like people would be at like, oh man, this got super early lockup. Like it was totally a good thing. Like that was
definitely a big market trend.
Of a good quality. And obviously it still had to not slip. You know what I mean? But if you had one at like 5% and it didn't slip, that was a quality build, So
for sure,
people tend to kind of frown on that a little more these days. Most people, there's still a few that like the super early, but and I think the premise behind that basically is that the earlier the lock is, the more life you have before the lock starts to wear out. Because guys, these things we've told you before, these, the steel and certainly the titanium is not nearly as indestructible as you think it is. Mm-hmm. So it will wear some over time. Now, under normal circumstances, and even if it's been flicked open a bunch, if all the geometry is done correctly, it's still going to last you a really long time. Like it shouldn't wear. Now you may see a little bit of settling in from where you first get it brand new, and stuff. The metal kind of. I mean, there's a lot of times there's a little bit of deformation. It's not saying bad
slander
about the other. There's a lot of slander going on there. No, there'll be deformation. So it'll start to. Did I say it right that time?
Yeah, you did.
Okay, deformation. Let me say it like a redneck.
Yeah.
It'll basically, the lock bar can, especially like on flippers and on like ones that are made to flick open like ours are. It is not unusual to see a little bit of indentation in the lock bar, just because when you're flicking something open as hard as you can, like and doing it, a gajillion times as you sit there and just fidget flick it while you're watching a movie or something. Like it is going to cause a little bit of it's going to dent it a little bit or whatever, but usually it does it to a certain amount and then kind of settles in. Unless you do something really drastic to it, it doesn't really change a whole lot for a long time.
Yeah.
So that's another reason to stay a little bit on the early side for us. And also, we have found that, like I said, there's like a middle ground there where it's, you either stay a little early or it's probably going to be what we would consider late, because we try to stay at least on the, less than 50% side. And we typically don't send something out the door if it's even at 50, much less beyond 50. But what we found with these radius locks is like there's not a lot of middle ground there. Like if you don't stop at 20-30%, then you're going to end up at probably 45 to 50%.
Yeah.
It's almost impossible to get it to land anywhere in between there. So we shoot for right in that kind of 20 to 30, 35% as well.
Yeah.
And I think that's a good place to be. It's plenty enough lockup that it shouldn't be any danger of slipping, even if you have a little bit of slight imperfection in something, it gives you a little more wiggle room there, but also still leaves plenty of life on it to allow it to kind of settle in a little bit. So
definitely. So yeah, is there anything else on locks you want to?
Around it a lot.
Yeah.
I'm not sure how good the explanation actually was. Like I said, we really needed like a big giant, like 3D printed or something, like to take it apart and show all this stuff.
Yeah. Because it's a tough topic to try to, because you're using a lot of, visual references of top, bottom, up, down angles. And, it's, but, and, another thing I guess to mention is I do titanium on steel. I know you do titanium on steel. And there's nothing wrong with that. I'll say it again. There's nothing wrong with that. It works.
I cannot tell you how aggravated I get. Well, they just upgrade to a steel insert now. Like it's like that's that dude. Like, okay, couple things. Number one, we already mentioned it earlier in the podcast. Kind of, Chris Reeves knives. I think kind of technically Chris Reeves and Michael Walker kind of came up with the frame lock about the same time, like on completely different continents from what I understand. But I think it's the frame lock part is more typically referenced as Chris Reeves'
The
idea. I think
Reeve integral lock
the
is
Reeve integral lock is kind of the technical standard name for it. So, reason I'm bringing that up is, crap, should have put my phone on silent. Sorry, guys. And spam risk, of course. They, to my knowledge, unless they've done it just on a few special runs here or there or something, they've been making knives for what, like 40 years or something,
something like
making
that.
the frame lock.
Mm-hmm.
And to this day, they don't use lock bar inserts. So,
Well, they did switch whenever they switched to the Submenza 31. They started using basically an oversized detent ball that sticks out of the lock face. They had been doing that with some of their other models, and the ceramic detent ball is actually the lock face now. But
okay, I didn't know that.
that was, 4 or 5 years ago whenever the 31 came out, basically.
Yeah.
And a lot of people were
I
upset
don't know
about it.
That's. I guess I don't know. I mean, yes, it kind of serves the same purpose in some ways. I guess but I think they probably just thought that was better overall.
Yeah.
For the lockup to. I mean, kind of the same idea as the steel insert, I guess. So, but still, they've been. I mean, it's only on a few of the ones that they make. The majority of the knives that they've made over the last 40 years or however long they've been doing it have been titanium on steel. And so one of the reasons I think that basically I see it as kind of like a cop out. Like it's because people cannot get the geometry and everything right. They can't get and go back to something you mentioned earlier. Like you were talking about what grit belt you ground it with. We actually use like a 220 grit, and like the grit finish that you leave on the lock face makes a difference. You get it too slick, it can make it slip. You get it too rough, it can make it stick. Like lots of things, and obviously we carbonize our lock faces. Like we have most of the time we double carbonize them. They actually get carbonized before and after. Most of ours, not all of them, a lot of them, we actually heat treat essentially harden the lock faces with a torch.
Yeah.
As well. Like we go through a pretty good bit of trouble, a pretty good bit of pains to make this thing work right in the most basic fashion that we can with as few parts as possible.
Yeah.
If that makes sense. So,
I mean, so I own folders with both inserts and without inserts, and I've had lock issues with both types. It is not a magic bullet. It is not a, superior mechanism by any sense of the word. It's a different way of doing it. I'm not saying it's wrong, but it is a different way of doing it, just like stock removal versus forging. It's not,
Yeah, man. No, I'm not saying it's wrong. I definitely obviously don't think it's wrong to not have it, even though that seems to be some of the opinion out there. And I think that comes from the fact that so many of the production companies do it now. But guys, the reason that they're doing it is because it makes it easier on them in the manufacturing process. It's not necessarily because it's a better end product. It makes it easier on them in the manufacturing process. They don't have to be as cautious and take all the steps to make it work right. As far as, especially on the sticking and stuff, it also gives them options if they accidentally overcut one to, have lock face or the inserts that are slightly,
heavier.
Some are slightly longer and shorter than others. So if they accidentally cut a lock too short, they can just pop a longer lock bar in there or a insert in there and recut it to that or whatever, which is not a bad idea.
No,
but they're doing it for that more than they are because it's a superior design.
Yeah.
And I don't know. I've always seen it as kind of a crutch that, for people that either didn't know how or weren't willing to make it work right without it. And I feel like we've got that dialed pretty good. So I don't feel the need for it. I'm not going to say I never will change my mind because anything could happen. And again, we get to doing high enough volume and it makes sense from the manufacturing side and makes it easier on us. And it's not technically worse or wrong, then, who knows, we might do it, but I don't have any plans to do it in the foreseeable future. So,
yeah, I just wanted to throw that in there because
good point.
Hear that, often. Like,
we do too.
One of those things that just gets under my skin. That and like over travel stops are somehow seen as a necessity. I mean,
right.
But
again, I don't think that that's a, I can see the principle behind it or whatever. I definitely don't think that they are a bad thing.
No,
But I technically don't see. I am not easy on anything. Just like, you know, I'm
I've never
rough on
overbent a
everything.
lock bar unless it was on purpose, like where I was
Right, and that's what I
intentionally
was about to
trying
say.
to bend the
Yep,
lock bar.
that's right.
And
And so
I've got,
I don't necessarily, yeah,
yeah, I mean, we've got, not bragging or anything, but knife makers generally have pretty strong hands. We use them all day long, gripping very small things generally, and making them do what we want. It's there's a fair amount of strength in my hands, and I've never once had that issue. Never
yeah.
needed
No,
the
I've never,
knife to stop me.
yeah, I've never accidentally hulked one over there.
Yeah,
It just hasn't happened. I understand the theory, and I don't think it's a
yeah,
bad idea. I certainly don't fault anybody for using them, but I don't think that it means the knife is inferior because it doesn't have it either.
yeah,
So that's, yeah, it's an extra. And like I said, I kind of lean towards the side of having as few, especially moving parts, few different components as possible on the knife versus, you know, adding a bunch of extraneous hardware and stuff that might help something at some point, possibly, but you know what I mean?
yeah,
That's just not really my style.
yeah.
Again, not to say that I might change my mind one day, but that's, at this point in time, that just hasn't really ever appealed to me to use that. So, um, yeah, quick little anecdote about the lock bar inserts too. Like, guys, because I got some inside scoop on this. A couple of knife makers that we know, actually they've both been mentioned in this podcast, but we're working on a project together, and they accidentally overcut the locks, so they took too much meat off of them, and they needed to figure out a solution so that they didn't have to scrap parts, and they made lock bar inserts, and that was where lock bar inserts started.
Yep.
So not because somebody had some great idea and was like, oh, this is some huge improvement. It literally came, like I said, it was a way to make the manufacturing side easier. Like, whether you
Yeah.
make a mistake or whether it's just easier to keep it from sticking or whatever. Like, that's at least what I was told. That was the first lock bar inserts that were ever done, and then people kind of took it from there and ran with it. So, and
that was
now, like
what
I
I
said, you
always
have
heard
people that are,
too, and it was basically a solution to that old problem of you can't put material back on after you take too much, and they sort
in
of
that
did.
case, you can.
Yeah.
Yeah.
But so yeah, that was what I've
Yeah.
heard as well.
Yeah, and just on one more quick note too. So on that note, guys, like I was talking about, if a company has, say they cut a bunch of them to cut too much off the lock on the blade, and then it won't fit in the handles. Well, we address that too, but we just choose to do it differently. Instead of putting a lock bar insert on there, I will actually make handles where I will, and most of them are pretty much imperceptible to just look at them and look at the difference unless you look really, really close side by side. But if we get several blades stacked up that we've accidentally cut too much and we can't use in our normal handles, I've got programs made where I basically have just moved the line where that cut is, because we're talking about
That's
like
smart. Yeah.
maybe 10 thou, something like that. And basically I make a whole set of handles. So if you ever see one of our knives, you take it apart and it's got an L labeled on the inside of it somewhere, or if it's got the S. So, and we don't do that. We haven't, well, I'll take that back. We have done it on a few of the Dixons already. So that's either like standard or late handles. So like, and we say late because we had to like leave more meat on the lock bar so that then we could have a chance to recut the locks, just like same purpose as we just said of a lock bar insert, as far as giving you another chance at using that blade.
Yeah.
But there's so little noticeable difference. You're talking about like maybe, I think the typical late handle we have like maybe 10 thou to the lock bar, and so a thou is basically a human hair width. So you're talking about like 10 hairs side by side is how much difference there is from one to the next. But it makes a huge amount of difference in the lockup. You can have one that's locking up at 90% and add 10 thou to the lock bar, and it'll it may be locking up at 5%.
Yeah.
So yeah, we
to
do
once
that.
again drive home how much how minute the differences is, or the difference is in bad lockup to good lockup.
Yep, it is a tiny amount. So anyway, hopefully we kind of, some of that at least maybe made sense. It may not have all made sense, and maybe we can throw up some videos. I'll try to do a little video of our lock cutting fixture. And again, I got to give all the credit to that to Les George, because I 100% copied his setup on that. Yeah, well, I guess we probably changed it a little bit as far as how we're putting the stop pins in there and stuff like I was talking about. But same basic idea is what he showed me. So I try to maybe get a little video of that and post it up so it'll as a little follow up, so it'll make sense. So
I'll try to do the same. I think I've got a few locks to cut this week, so I think I'm getting back into the folder swing now that the Mark show's over. So
good.
That'll be fun.
Quick little,
Nothing. Go ahead.
I was just gonna say on that note, a quick little plug. I actually did a whole this past week. I did a bunch of footage and did some explaining stuff in there and just showing some stuff around the shop, kind of a vlog deal for this past week. I did not post it on the Knife Freak Show channel. I probably need to, but I posted it over on the McNeese Knives channel. So if you guys want to check that out, we were talking about doing some videos like that. It made more sense for me to just post it on our channel. Yeah. But I'll
put a link to your channel in the description.
That'll work. So keep an eye out for that too, because I may still, since we're not super active yet on YouTube on that channel, but I want to get more active. So just instead of having to be redundant and put it more than one place, I'll probably post most of our stuff there, so you can just go over there and check it out. But on that note, I guess it's probably getting close to time to wrap this up here and lock it up, so to speak. So give them where they can send us questions and stuff real quick, if you don't mind.
Yes, sir. You can send your questions and concerns and comments and ideas to knifefreakshow@gmail.com. That is knifefreakshow@gmail.com with one S. Find us on, like he said, YouTube for him, and also Instagram, Facebook. Also have Instagram and Facebook, McNeeseKnives.com, BoatRideBladeWorks.BigCartel.com. And like and share the video as well, and the podcast.
Yeah. Okay, cool. So no reason not to check everything out, guys. We do really, really, really appreciate you guys' support. So we're humbled every time we get a chance to go and talk to people, especially in person at shows, of how many people are actually listening to this. So and or watching it. So it's pretty cool. And
on that note, shout out to Bryant Hollinger. You know Hollinger as well, but he's a really good knife maker from down south in Alabama, and he said he learned about the podcast at Blade Show, I think, and he's been catching up ever since. So we appreciate the support, Bryant.
Absolutely. And you guys, please continue to, by all means, it helps us if you leave us reviews, especially on all of the different avenues, whether you're listening on Spotify or Apple or wherever, and on YouTube. And by all means, please leave us comments and suggestions for things that you want to hear us talk about, questions, that kind of stuff. Please hit us up with those, because we love doing that stuff. That's actually a lot of fun for us to make. Some of those questions have been really good and made me think about stuff that could actually be very helpful to us down the road. So yeah. For sure. All right. Well, on that note, I think we will plan on seeing you guys next week. We appreciate you.
And let your freak flag fly.